Welcome to another fantastic episode of the AI Show. Only fantastic because of you fine folks. How's it going? Where's everybody coming from today? Before we get into a summary, we have a good show today. Not the part where I mess up the code, because we're all going to mess it up together. Still doing JavaScript. What's up, my friends? Welcome. Where's everybody coming from? Anybody have a burning question? By the way, we have some actual, tried and true MLOps, ML engineers, data scientist, data engineer, and we're going to ask them all the hard questions. And they've agreed to stay after and answer any questions that you all might have. I'll talk about that a little bit. So I'm just excited for that. So, all right, where's everybody coming from nowadays? Where's everybody at? I live in a little town in Washington, close to the Microsoft headquarters. The Czech Republic. That is a lovely place. Absolutely lovely place. Absolutely lovely place. Spyros is telling my music, so I'm turning it down, Spyros. I got you, buddy. Absolutely lovely place. I went there and I just walked around and took it in. Beautiful place. Santa Fe, Argentina. Pablito. We should do like an all Spanish version of the show one day. Just be like, we're doing it in Spanish. Bienvenidos todos al show de IA, donde vamos a aprender cosas, elevarnos y ser más dignos de IA. Sorry, I waxed poetic in Spanish. There's a lot of blatherskite. Manchester, UK. I love the UK. You know, if I was asked, do you want to live in another country right now? It would be the UK. I might change my mind in 20 minutes. Don't ask me in 20 minutes. Welcome. Manchester, UK, welcome. Use ML. Use ML to add something. Yes! You sure can. Oh my goodness. Yes, Pablito, I do speak Spanish. But I don't know if y'all know this, but I grew up in Mexico when I was a kid, from like when I was 5 till I was 8. And then when I was older, from when I was 19 to when I was 21, I lived in southern Spain. And so my Spanish is weird. Super weird. South Africa, also a lovely place. Literally the last international trip I made before the Rona. Before the Rona. It's awesome. Like, I love being there. I was supposed to go again. I went to some really cool places. India. I've only been to 2 places in India. Mumbai and Bengaluru. That's it. But I loved every minute. I was talking to the taxi driver when I landed in Bengaluru. And I was like, how many languages do you speak? I love languages. He's like, well, I speak Kannada. And I speak this other one and this other one. And those languages have nothing to do with each other. And it's just, you know, some are from Dravidian family. Others are Proto-Indo-European based. It's just absolutely cool. Love India. Very rich cultural place. Brazil. I've also been to Brazil. Lovely place. The thing about when I speak Portuguese is I kind of have to go like that, and then I kind of understand them. All right. I think we should talk about what we're doing today. I've got my handy dandy kabow. I'm gonna write this down. Number 1, most important, we are going to talk to some data scientists, ML engineers, and data engineers. Hopefully David can come back. I don't see him. We should ping him and make sure he can come. We're gonna do a high level MLOps. You know how like people started like being like, you should just use DevOps, and everyone's like, well, what does that mean? Now we're doing that, but with MLOps, high level MLOps from real. I'm gonna I'm gonna change the color of this. Real data scientists. All right. I'm going to turn that other one off. Real practitioners. I'm going to use the word practitioners because it makes everything sound fancier. Real practitioners. Number 2, I was given a tip recently about how to use my Onyx models in the browser with WASM. I'm gonna find that email. I haven't even fired. I'm gonna be honest with y'all. I haven't fired up, so we're all gonna have to remember what the heck we did last week. But we are doing the whole inference with JavaScript. JavaScript in a React app. So that's what we're gonna be doing today. Remember, we had the backend API. We'll see if we can get this to work. We got it close, but we had a little Batman problem. We had a bunch of nans. Batman. Batman problem because his nans, bunch of nans in a matrix. Nan. Do I have to spell this out? I guess I do. And then we are going to move this up. Let me move this up here. Move this up. And then we're going to see if we can't get the magic to work in the browser. Work in browser. Has anyone ever called it the Batman problem, though? Am I the first one? Because remember, we have decided that we are full stack AI developers. That's what, you know. All right, so I think it's time to bring our guests. I think it's time to bring our guests on. Let's see. All right, let's see if I can make this work. We're gonna go here, and then I'm gonna add Spyros. Hey, Spyros. Hey, David.
Hey.
Where's Sam? Did he just jump off?
I think he will be joining us.
Oh, I hope so. Because I mean, should we start without him? I feel like I don't want to start without him because he's so cool. He's typing at him right now. How you doing, my friends?
I'm good. I'm good. Thanks.
Nice. By the way, everyone that's watching, David and Spyros, and hopefully Sam, who was here but he dropped, and maybe the internet. He's coming from, where is he coming from? India, right?
Mm-hmm. Yep.
And David, you're in Italy.
Exactly.
And Spyros, you're in the UK.
Yeah, I'm based in Edinburgh, in Scotland.
Two things. Thank you so much for being here. Next thing.
Thanks for having us.
Dudes, I'm so sorry for ruining your Friday night.
No worries. No, this is the best Friday night so far.
You're too nice, man. I appreciate it. All right, so what's the deal with Sam? What did he say? What's he telling us here? Let's see here. Hold on, I gotta log in. It's like the camera doesn't see me. Okay.
He's in backstage, probably.
Oh, there he is. Oh, wait, hold on. Yeah, I see him. Let me get it. Oh, there we go. Sam.
Hey, hi.
Hey.
Two things. You were here for this. Two things. Number one, thank you for being here. Number two, it must be like midnight over there, Sam.
Yes, it's like 11:40 p.m. right now.
Dude, I'm so sorry. So look, I'll tell you why I had the idea for doing. I don't know if people know this, but gentlemen, you tell me if this is a good idea or if we should change times. I was thinking, what's the most chill time to have an AI show? And I thought, well, right before lunch and during lunch, 11 to 1. Because it's like, I can eat my lunch. My boss comes, like, you're taking a long lunch. Everyone would be like, oh, no. I'm taking a training course from Microsoft about AI. And I could be someone's, excuse for a long lunch. I never wanted to be an excuse for we're staying up till midnight. So apologies.
No, this is actually good. This is actually how it usually works in the projects. Like we join late in our time zones, and then some is like super late.
Oh,
exactly.
Time zones.
Oh yeah.
So sorry. Do you shift? This is not part of the show. We'll get to the serious part. But do you all have to shift your time zone sometimes for some of your customers or your clients?
Yes, regarding for whom we are working.
Oh my goodness.
We are flexible. We are engineers. We are flexible.
Nice. Okay. All right. So let's get down to business here. We're gonna do this show here. So just a couple of things. I'm going to put the title and be like, you're not going to miss this episode of the AI show where we talk to blah, 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 blah. And then I'll put the card on. And I'll be like, welcome to this episode of the AI show where we're going to talk to some real data scientist, data engineer, and data ML engineer about high-level MLOps from Microsoft data scientists. I should have put the other ones too. I might have to practice. I'm not going to mess up. And then I'll play the card, which is this. And then we'll chat, okay? And friends, for those of you that are here, I actually wrote down questions, right? Because I work in the product group, right, which makes Azure Machine Learning and Cognitive Services, and so we make the thing. But I always love hearing from in the trenches, like folks, like in the stuff that they're using. There's a lot of good products out there, and etc. All right, you gentlemen ready?
Yep.
Absolutely.
All right, this is the serious. Now we're gonna do the thing. I'm gonna make sure I can see all of the comments. Okay. Hold on. Okay, cool. Okay, everyone's ready. By the way, get your questions going. We'll go through them at the end. As always. All right, here we go. I'm not gonna mess this up. You're not gonna want to miss this episode of the AI Show where we talk some high-level MLOps from Microsoft data scientists, ML engineers, and data engineers. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking to some Microsoft data scientist, a data engineer, and an ML engineer. It sounds like the beginning of a really fun joke. They all walked into a bar. What happened? We're going to talk about high-level ML ops. So why don't we start with some introductions? Spyros, why don't you start, buddy?
Great. So I'm Spyros. I'm a data scientist with Microsoft, and we are here joined by my esteemed colleagues Davide and Sam as part of an AI task force, a data scientist, an ML engineer, and a data engineer. And we're part of a wider team that covers EMEA and worldwide time zones. And what we do is that we enable our customers to formalize, design, and implement data science solutions in Azure. I'm the data scientist of this team. Pass it back to you.
Let's go to Sam.
Hi, my name is Samarendra Panda. I'm the data engineer of this team, and I work as a data and AI consultant for Microsoft Industry Solution team.
Fantastic. David.
Hi, my name is Davide Fornelli. I'm based in Italy. I'm part of Spyros of the Customer Transformation and Innovation team in Microsoft. In this AI task force, I cover the role of the machine learning engineer.
Fantastic. So I know you can't talk about customers in general specifically, but what kinds of projects do you work on? I'm sure it's a bunch of them. Who would like to speak to that?
I'm going to speak about that. So the latest project that we have delivered, and as part of this particular task force, was with the largest UK energy supplier. And that was a supply and demand optimization problem. Combined with field service appointment optimization. So it was a lot of overlapping ML models working with each other and on top of each other. Another one before that was with the world leader in shipping. And that was about fuel consumption optimization and route optimization using onboard IoT sensor data. And the list goes on. There's multiple projects across all disciplines, from finance to healthcare to anything you can think of.
So when we're talking about these particular projects, are they all like completely different from one another? I'm sure there's aspects of that, but are there common things as well that you see in them?
Yeah, absolutely. They can be very different in terms of the context or the domain. But when it comes to AI and ML, there are a lot of common patterns, and especially with our experience delivering such projects. And this is the topic of today's show, I guess. One of them that stands out the most is how important it is to do proper machine learning operationalization, aka MLOps. How critical it is and what effect it has downstream for a project.
Yeah, and I briefly showed the screen, right? The whole concept of MLOps, but for delivering value, which is pretty cool. So let me ask this question, and let me point it to you, maybe, Sam. There's got to be some common like pitfalls that people like jump into when they're doing these projects. What are you finding that's just the common challenges? We'll go to you, Sam.
Yeah, so that's a very good question, and I would like to talk from the data perspective, and then I'll hand over to Davide to talk from the machine learning perspective. So let me just talk about the data from the data perspective. So in my experience, I've seen that, most of the time in any of the machine learning projects, the main concentration goes into the model training or optimizing the model to get the better performance metrics or scoring of the model. Uh, Although, I believe that, these are important. However, not having an automated data ingestion pipeline as a step or part of the process makes a better model perform really bad over time. If we are not training the model with the recent data, the model will be biased towards the previous version of the data, which is really bad.
Right.
uh, and then one more problem what I have seen is basically the integration point between the data scientist and the data engineer. I'll just give you an example. So let's say that the training script, the model training script doesn't need lot many features. It just needs couple of features. But the data engineer who is working on the project or the data ingestion framework is basically sending lot of attributes or lot of columns to the training script. Or let's say that the machine learning model is supposed to train the model on a specific hierarchy. Take an example of geography hierarchy, and the training of the model is basic. The training of the model should be done based on the country, but we are supplying the data or we are providing the data based on the city level. Hence, what's happening that we are providing lot many columns, lot many rows, and that basically makes the training of the model becomes really slower because we need to do some kind of overhead functionality like aggregating the data or feature engineering and all those kind of steps we need to perform just before we actually get into the actual training algorithm part. So I believe these are the main pitfalls or the problems what I have seen in any kind of machine learning project.
Yeah, and just to summarize, I love the look. I went to school and did research, on like building machine learning models. So that part is super interesting to me. But your model's only as good as your data process. I think that's what you're saying, right, Sam?
Yes, that's true. If the processing of the data is not great, or if it is not automated, or if it is not meeting the SLA, then no point of having a good model because that will perform bad over time.
Cool. All right, David, what are some of the common challenges that you're seeing?
So I would like to take it a little bit far the answer. So there is a reason why in the sentence data science, there is the word science in it. It is an exploratory activity that, given a thesis, it requires experimentation to prove its feasibility. So this means that more are the experimentation cycles that you can complete, higher are the chances to find a solution for the hypothesis. The experimentation cycles are also useful to gather a better understanding of the actual business need, because sometimes we start with the customers with an overview of the business need, which is going to become more specific across these kind of cycles. So it could also happen that the business need that we used at the very beginning, at the origin of the project, is going to change over time. So the experimentation velocity of these cycles and the solution flexibility that we are delivering, which has to be capable of shifting depending on the business needs, are two of the main pitfalls and key features that we have to manage in our project.
And that's really cool because, I mean, the word science, everyone thinks it's like, oh, it's so scientific. But science is really a rigorous process of guessing and checking. I mean, am I saying that right?
Exactly. That's perfect. That's perfect. And more experiments we do, higher chances we have to solve the business problem. So to be really quick, so the concept of velocity here comes from the agile methodology. So we apply the concept of velocity of the development team to the velocity of the data science team. Okay, so higher is the velocity, more experimentation can be able to do, higher the chances to reach to the solution of the business problem.
That's really cool. Spyros, what are some of the challenges that you've seen, my friend?
Yeah, so following up from what Davide said about science, we have to remember, right, that you can get a PhD by trying to prove something and getting to the point where you can prove that it cannot be done, right? So that's one thing that the customers never have in mind. That's one thing that sometimes it's not possible. And then building up on that, it's the thing that what I find the hardest from a data scientist perspective, in close contact with our stakeholders and the business customers, is that first of all, the MLOps part is very often either varies from being underestimated or being missed completely in the planning stage, which is a big problem. Then the most of the difficulties we run into have to do with the definition of the data science user stories and targets, and the definition of done and the success criteria. For example, what should be the evaluation metrics that we should choose? When is a model good enough? Is 90% good? Is it bad? Should we try for 91%? And when do we accept that there is a realistic value for those metrics to be successful? And when are we done with the experimentation? So those conversations are very, very important. And another thing is that very often it is difficult to decide when we should actually go for data-driven modeling approach versus subject matter expert inputs for decisioning. When should we go with the data, and when should we go with the experience and the gut feeling? And both of those things built on top of everything else that the guy said.
I personally think, I know we should think about these things, but what does it mean to have success? What does it mean to be done? And then maybe we don't need this at all. I mean, I've had customers come to me and ask me, "Hey, I want to do this thing," and I'm like, "Hey, that sounds like a database lookup, and not actual AI." Have any of you had something like that as well?
Yeah, it's actually funny that this is so. Working for Microsoft has this good thing that we're not going out there we don't have to sell something by force, Right. And that gives you the flexibility to operate with honesty and transparency. And I find it, and we've all seen that with our customers, that they really sometimes they're flabbergasted when we say, "That sounds cool, but we're not going to waste your time. It's not going to work. It's not going to bring you value. There's no point in doing that. Here's how you can do it another way, cheaper, faster, and without going into the whole big data hype." And that, having the ability to do that builds trust, and it's the best way to go because it's like the honest way to go. So, and if we are realistic, there are some cases where you don't need to go with deep learning, for example.
Yeah. I mean, I always start with decision trees and logistic regressions, and always start simple and then get complicated when you have to. Here's another question. I'll put it to you, David, and then we'll cycle through. We've talked about the table stakes challenges. Have there been surprising challenges as you've worked with customers that you're like, "Oh, this is interesting. I need to make a mental note of this for next time"? What do you think, David?
Yeah, so as a machine learning engineer, I like to think about the life cycles of the models. So one of the considerations that I make, and I do this also with our customer, is that the model's environment is different between the POC, where you study the model, and the real world, where you're going to use the model. So during our design sessions with the customers, I typically suggest to experiment with the real world in mind. Something like so keep in consideration how the data is ingested, as Sam was mentioning. How is the scoring done? Which are the timings constraints for the training and scoring? Which is the source data during the training and the scoring stages? And the list goes on. So designing a machine learning solution, so what we do as consultants, is not only about designing the architecture, but it is mainly about designing the overall life cycle of the model.
Interesting. Spyros, some other surprising things?
Well, that's kind of an easy one, because it is surprising, even for me, how often the customer will underestimate or overestimate the quality of the data that they own. So we see it's pretty often the case that people are influenced by the tech sphere hype, and they go after high complexity use cases that are very challenging to even define. And very soon, I mean, if you know what you're doing, you can very quickly spot that either there is no data available at all for that use case, or that the granularity or quality or frequency of the data is not appropriate for that kind of problem. So what is surprising, and it shouldn't be surprising, is that big data by itself cannot solve any problem, and AI, with big data, it has to have some quality aspects that come with it. Another point is, which I find surprising, is that it's still the case that many times we see that a business will find it, will think that it is almost equivalent to replace data-driven structured data flows with people-centric flows, and to have the belief that the people-centric flow will either be less error-prone or at least as good or as fast as a fully automated pipeline. And this is what we do, basically. This is where we come in and we explain and demonstrate with POCs that that's not the case.
Interesting. Sam, let's go to you. Surprising challenges that you found.
I'll just talk about the real the development scenarios. So for example, I have seen that if you go to any customer place, and they would be having so many models, and now they probably be choosing any tools for the machine learning, like any compute there will be, which would be there to train the model or inference the model. But one common thing what I found, that let's say there will be some common script, like creating the compute or creating the data store, creating the mount point, everything will be scattered, and all the machine learning model would be having their own version of the script. Now, like, there is no modularization, there is no module concept, or nothing is there. So I really found it's really difficult to work in those kind of scenario. Let's say one data scientist working in some part of a machine learning model. Now, let's say he is going to shift to a different machine learning model problem. Then he needs to go through the whole framework again, because that has been coded differently. So I believe if we do not have any kind of standardization or the uniqueness in the framework, that will create a lot of problem. Because in the machine learning process, what I feel, only the changes what happen is the input, output, and the environment, and the training algorithm. Everything else remains same, and that everything else can be standardized across the organization, across the different machine learning problems.
And that's really cool, because I think it's hitting on something that this is what I want to get into now. You talk about standardization. My sense is that some patterns emerge the more customers you work with. Can you talk about those patterns a little bit? We'll start with you, Spyros.
Yeah. So basically, what we've realized is that the main pattern is that it's not enough to have data science and AI involved in a project. You have to basically have a solid and flexible framework for machine learning operationalization, MLOps, as we call it, which covers three basic principles. One is that obviously it follows the DevOps methodology for machine learning. Then it uses the machine learning technology and enables the models to go end-to-end to production. And it also allows for an agile culture. So it needs, this needs to be in place so that we are flexible and we don't go down the road of chasing down a standalone use case and go waterfall trying to solve it, and then only to realize in the end that we need to change course or rebuild or throw away everything we've done for the last 4 sprints, for example. So only if you have a solid and flexible framework for MLOps, you maximize your chances of being prepared for any eventuality, and maximize chances for success.
So let's talk about, because we kind of been dancing around this notion of MLOps. How would you describe MLOps? Who wants to take this one?
Spyros, you can go ahead with the discussion.
We have the deck. I think we can bring up the deck. Yeah,
bring it up here.
So this is what it looks like. MLOps in delivery, what it looks like in real life. So MLOps is a set of practices and rules that allow it follows the DevOps guidelines for machine learning. And in terms of the technical aspect, there is not a lot of differences. What we're showing here is what it looks like from the people perspective. That the mission, what we do as an AI group here, the three of us, is that we go in and we have overlapping skills to some extent, but each one are experts in our area. So the data scientist will be covering the modeling aspect and creating the model to solve the problem. The ML engineer will also heavily participate in that, and also in tuning and operationalization. And the data engineer will be predominantly doing all the implementation of the pipelines, the environments, and the framework. And what's important, what's the key takeaway from here, is that it is about not just the methodology, but also the technology used and the culture. So you can't have one without the other. You can't run this successfully without having a very competent data engineer, for example. There is, unfortunately, I'm going to spoil this for you, Seth, that we can't have a unicorn data engineer or a unicorn data scientist if we're talking about a serious level of commitment of a project. If it's a standalone POC or a hackathon, you can do those things. But for a full-scale operational project, for a large customer or a large organization, you really need to have the interoperability between these three roles. And that's why we are successful when we go in like this.
That's interesting. David, do you have something to add here?
Yeah, so in the next slide, we're going to discuss also about which are the principles, about the MLOps in delivery. So basically, the principles are four. When we deliver something, we are based on 4 pillars. The first one is the change management. So also this is something that most of the time is underestimated, because when AI is involved, it's going to change some business processes. The solution that we are going to make is going to be used by someone from the customer side. So we need to take care that the customer and the team of the customer, so the end user, is going to be able to use what we're going to deliver as its best. Okay, and without any sort of fear, because sometimes AI is perceived as something that is going to replace the human being in their own job. Instead, AI, what the solution that we do, also for a concept of responsible AI, is something that is going to help the end user. It's not something that is going to replace the end user. So it's something that is going to be used with the human being, not in place of. The other pillars are more about the delivery, the technical aspect. One is the development environment, which is something, well, there are many types of data scientists, like as software engineers, you could have different flavors. I would like to use Python, I would like to use R, I would like to use Scala, and the list goes on. What we take care about is also to try to, let's say, establish the language. Let's say Python, okay? We are going to put all the software engineers, all the data scientists in a condition to be able to work in the same environment as quick as possible. So typically we use a Visual Studio Code with a Docker environment, which is going to be attached all together. And we're going to also create an environment that is going to work remotely with the cluster, with the compute target. These are technicalities that sometimes are kind of underestimated, because working with a remote Spark cluster from the local environment, it requires a lot of configurations. So if you have another team member that is going to join the team, you have to put him or her up and running as soon as possible. Another thing, another pillar about the more technical aspect of the model is that we have to be able to basically log everything. I love logging. Logging saved our life, professional life, many times, because when the model breaks, it's not going to send you an email, hey, I'm going to break, wake up. It's going just to break, and that's it. So you need to be, since sometimes what we develop, sometimes most of the time what we develop is mission critical, because we have the skills to commit to such missions. We need to be able to, if something breaks, to fix it as soon as possible. And logging the models is not that easy as it could sound. So we put it in place, a framework, a methodology, also to ensure that everything that is developed by our teams is going to be logged properly and is going to be easily searched when it is needed. The last pillar is also the architecture. So we need to be able to deploy the architecture in different environments in the same way every time. The customer can have dev, prod, test, pre-prod. Another environment which is a simulation of like a digital twin of the production environment and so on. So we need to be able to deploy the established architecture in every environment with ease, like with just one click. Okay, so this is mandatory also. All these things help us to improve what we were saying before, so the velocity of the experimentation and to increase the solution flexibility. Okay. So these 4 pillars are helping us to achieve to solve these 2 pitfalls actually that we were discussing before.
That's cool. Sam, what are your thoughts on MLOps, my friend?
Yeah, I think almost Davide has covered all those aspects, but I think I'll just try to add the data aspect of it, because as I have been saying, without data, a model can't be a better model. So the only things which I can think of, having a good integration point between your data pre-processing and the machine learning model training script initiation. So for example, I'll just take one example. Let's say you have an Azure machine learning service. Now, you probably be doing the data pre-processing somewhere else. Then, you should be having a pipeline, which basically tell us that, when the pre-processing of the data finishes, then only you start the training. Like, you should not run in a silo mode. That should be having a good integration in between. So that's something I can talk about, like, make it a like data pre-processing or the data ingestion should be the integral part of the whole MLOps life cycle.
Yeah, and this has been super good. Let's just finish off with this, because all of this information has been good. I love the pragmatic approach to this. It's not like, hey, this is magic. No, it feels like it's actually engineering, the stuff that we've been used to as programmers since forever. Any tips from any of you on someone that's like, yeah, we have a nascent machine learning practice that we want to start in our organization. What are some tips that you might have? We'll go to you, Spyros.
Right. Yeah. So I'm gonna touch on some things that we mentioned before. So I would say number 1 would be invest the time in the beginning to be very mindful, actually, to not overinflate expectations, and invest the time to explain that this is a scientific experiment, essentially. And anytime that you invest in the beginning to set up your experiment, to set up your target, what you're going after, as clearly as possible, it's going to pay off in the long run. Another thing I would say is avoid going for the solo superstar approach, but get yourself a proper task force of experts like we are talking about here, so that you can cover, even if there is overlap, but you can cover all of the things that you need to cover And another thing that I would mention would be, again, pay very much attention to clearly articulate to the stakeholders what the possible outcomes can be of the experiment with ML. That it can be total success, total failure, and anything in between. So we have to be prepared for that, because one of the most common pitfalls that we didn't really mention was that many times in a project, the component of AI is considered as done before we even start, that we are certain that the outcome will be what we expect it to be. And we only come back to pay attention and realize that it is central, mission critical to the whole project when things go wrong. So way better to do not overinflate expectations, explain the possible outcomes early on, and pay attention and staff properly when you go in such endeavors.
Great tips. Any from you, David? Tips?
So like Spyros gave already some great advices. What I would like to add is just a repetition of what we said before about the architecture. So when you're putting in place a team, try to make, as Spyros said before, like there is no unicorn, but you could have a unicorn team. Okay. Once you have the kind of team, when you design your solution, keep in mind the model lifecycle. So basically, do not rush into coding the solution without having first in place clarified what you have, the full life cycle of the model, and experiment with the end goal in mind. Okay, this is going to let's say save your model life by far.
All right, to you, Sam. Tips.
Yeah, I think the tips is basically I'll just take the word called velocity, what Davide was mentioning, because as I work as a data engineer, most of the time what would happen when I'm starting a project, my data scientists would be waiting for me to process the data and give the data to them. So in those kind of scenario, I would rather be suggesting or can give the tips like, let's have a logical segregation between the different the roles and responsibility. Let's say data scientist wants to train the model, give him a quick snapshot of the data to him, so that he can start working on that, like he or she can start working on that. And by the time he or she finishes the model, you basically take care of the whole data ingestion piece, so that you can work parallelly. But that's something I can think of. And also, let's have a logical or the mutual agreement at the starting of the project when you are designing with the data scientist. Okay, what you need as an input, what environment do you need, and where you will be providing the output. I think being an ML engineer or the data engineer, these three questions has to be answered by the data scientist. Input means like the normal model the data which is required to train the model.
Right.
Environment means the dependencies, the Python dependencies and all. And then the output, where if you have basically trained the model, where you are going to save that trained model, so that you can basically integrate the DevOps pipeline and the other activities, whatever is there. But I think these three questions has to be answered by the data scientist to the ML engineer or the data engineer. This kind of logical and the mutual agreement has to be there at the starting of the project.
Well, this has been super informative. Where can people find you if they want to get a hold of you?
Well, we're all on LinkedIn.
I have your LinkedIn links here. So this is Spyros here. If you want to get a hold of him, if you want to get a hold of David, here's his LinkedIn address. And then if you want to get a hold of Sam, here you go. That's for Sam. Well, this has been awesome, my friends. Thank you so much for spending some time with us. And thank you so much for watching. We were learning all about high-level MLOps from Microsoft, a data scientist, a data engineer, and an ML engineer. Thank you so much for watching, and hopefully we'll see you next time. Take care.
Thank you.
That was so good. Oh, did Sam leave? Like he just left. No, Sam.
Went straight to bed, I guess. I don't know.
Poor guy. It's like probably midnight for him. All right, we had a ton.
Dropped. Instantly dropped.
We had a ton of questions. I am going to start looking at them and then putting them up here. Amazing insights from Martin AK. Yeah, this is good stuff. From Jay. Hold on. Jay's here. I got to say it the right way. Jay McCormick.
Is he a fan? A long-time fan?
Evan Oliver. Those two are here. Sorry, I had to get the. But yeah, this is good stuff. I actually really like the pragmatism. If I'm being completely honest. Jabulo said, "I don't belong here." Never said you belong here. There's room for everyone in tech. Here's another one that speaks to something you were saying, Spyros. People are bad at doing things fast and accurately and reliably.
Absolutely, yeah. That's what the whole concept of digital transformation is about. But there's, sorry to jump in, but there's two flavors. The one is what Davide mentioned, that we're not going in there to replace and take people's jobs. We're going there to make people's jobs easier so that they don't have to be in a position of making a call that some piece of code would make more reliably and better, but they can focus on other more important things rather than doing that.
It's almost like up-leveling what humanity is doing. Like, there is some stuff that we do that is just absolutely brainless. Like, let me move this from the website into an Excel spreadsheet, and then let me go to the next page and then move that number into like that kind of. I mean, you kind of roll your eyes here because you see that literally happening, and that's the data process, right?
Mm-hmm.
Wow. Okay, here's a question from Kevin Oliver. What skills do you look for in entry-level machine learning engineers to have for a new position?
This is a good question. So like I can tell you how I became a machine learning engineer. I started with being a pure data scientist, but I was coming from software engineering. So I studied computer science in university. You can be a data scientist from many, many different fields, Since I had this passion in software engineering, and since I saw that in our project where was missing always the last mile, which was the operationalization. So I started to get more focused. I went deeper in the topic, So the good point where to start is honestly just to do a lot of projects by yourself. This is how I did it, with the main focus of making my life easier in when I was deploying the model. So I try to challenge myself every time by optimizing my time as well. Operationalization is all about that, optimizing my time, our time.
Any other tips, Kevin, on what skills do you look for? Like if you were going to hire an entry-level machine learning engineer, what would be your suggestion?
I'd like to have a go at that as well. So from my perspective, at the end of the day, you have to keep in mind what I would be what I'm looking for when I'm working with an ML engineer is reliability and trustworthiness. So it's not about knowing everything. Nobody knows everything. And to be frank, all of those technical tools that we use are going to change in a couple of months, in a couple of weeks sometimes, right?
Yeah.
So it's not about knowing everything before you start. It's about being able to learn and building your confidence, and at the end of the day, not to be driven by fear. So what matters is to be able to say, I messed up, or I don't understand this, or I need to learn this, because it is very important to be able to trust each other. It's all about trust, and that's how you get reliability, right? And then from my experience, it has been many times the case where everybody was going crazy about some particular tool or a methodology about solving a data science problem, and it just didn't click for me. I couldn't go ahead. And it turns out that, trust, you have to reach the point of confidence where you can trust your gut feeling with those things, so that then you can go and say no. So like Davide will come and say, no, we're not going to do it this way. Or if these two models are equivalent, go for the other one, because that's going to make our life easier, and that's going to give us a better turnaround, a quicker turnaround, and better results. So going back to wrap it up, don't be afraid to expose yourself to learning new things.
That's cool. And I love that it wasn't like, hey, you need to know about Spark, Spark ML or Panda. It was more like, be reliable, learn fast, and trust your gut. Those are some really good advice, pretty much for almost any field. Sam, your thoughts on skills for entry-level machine learning engineer?
I would say, like, let's not focus on the technical side, because what I found, there are various tools, open source tool, and Microsoft has so many tools. Just try to understand the flow, the MLOps lifecycle, or the whole machine learning lifecycle is very important to understand. Then automatically you will be able to fit in the things in place. And we have sample codes everywhere running in the GitHub. So don't worry about the technology. Just try to understand which block will fit where in the lifecycle. That is very important as a skill set, I believe.
That's cool. And here's Rahul saying, agree with Sam, have to spend a lot of time for understanding and feeding training data. Should have some way to automatically generate training data and have a feedback loop. So people are a fan of what you said. And then here, Lefaxitifinum, treat your data engineers well. If you want your model, have good recent data.
Absolutely. Absolutely.
Yes.
Treat you good, people.
Absolutely.
All right, so there's some more comments here.
Honestly, Sam is the pillar of the team.
Sam
has all the weight on his shoulder.
Hands down, that's the case. Yeah.
Let's put our hands up for Sam here. Who does all the things. Hold on. Also, AI ops with ML ops. Most people have a hard time distinguishing the difference between AI ops and ML ops. I was told that AI ops is infusing your DevOps process with AI. And ML ops is the process of doing DevOps with machine learning, right? And it's different. Like, for example, you might build a model like that uses a machine learning. You might be building some software that uses a machine learning model during, release gates to test stuff. And so it's a really interesting. So that's why I put that up there. I like this. What about ops?
Probably coming up.
and then ops. All right, my friends, it's been a pleasure being with you. I am going to let you go to sleep. And again, I'm so sorry. This has been awesome. Hopefully we'll get this video out soon so people can take a look, okay?
Excellent.
All right, take care.
Thank you.
See you, Spyros. David and Sam. We'll see you later, buddy. How about those people, huh? Those were that was awesome. Let me clean up here from my friends here. Oh, Seth Juarez, code rushed. Hold on. Code rushed. I used to work at DevExpress. Wonderful place. Everyone except for Mark Miller. I'm just kidding. I owe them drinks for sure for having them on so late on a Friday. You are absolutely correct. And here's Janiscu 7. Yeah, I was thinking of, once I got like a prototype working, I wanted to have a way to start getting more pictures in, train better models that just don't recognize me. And so absolutely, I want to do that. Operationalize your operation. Yes. I got to read this name. Elephacitifinum. Is that Latin? Could you please recommend some good sites that have a catalog of deep learning architectures? Yeah, there's a Model Zoo. If you search Model Zoo neural networks, you'll find some. We'll look it up in a second. Latin. I got it right. Yes. Yes. Nice. I love it. Here's a question. Did Mark drive you insane with his issues? No. Mark and I are actually like the same guy. Like if you were to look at us standing next to each other. Hold on. I gotta find a picture of Mark Miller. Miller, do you have a picture I can use? Hold on. I'm gonna open the internets and find a picture of Mark Miller that you all can see. Here, Mark Miller. Mark Miller Dev Express. Because there's probably a ton of different Mark Millers. Hold on, let me go to images here. You're not looking at it yet. Okay. Here we go. Mark Miller is this guy right here. This guy. I mean, like, if we were to stand next to each other, you could not tell us apart. Absolutely no way. I mean, facial hair, bone structure, a certain je ne sais quoi. You know what I'm saying? Oh my gosh. There is a certain je ne sais quoi about Mr. Miller. So, yes. Except that one of us is better looking. I doubt that, brother. I doubt it. All right, we should probably get to work. Let's get to work. I'm gonna be honest. I had to do the get to work thing because I hadn't even opened the Visual Studio Code yet. Open recent. Drochambeau. Where are you? Drochambeau. Here we go. Oh, did I just leak a key? That key won't work, by the way. You have to be on the VPN for that to work. It ain't gonna work. Okay. So, what do we got going on here? Okay, I remember. We were getting some nans here. We had the Batman problem up in her. For those that are wondering what the heck Seth is working on, rock, paper, scissors. We're going to build like this interactive website where people can play rock, paper, scissors against me or my AI, basically. But I wanted to make it so that people could be like, rock, paper, scissors, shoot. You know, and the computer would just look at it and be like, oh, paper. Oh, rock. Here's a question. How does one get on the VPN? Asking for a friend. So, you have to get on bus number 7. It drops you off directly right in front of... I don't know. I'm just making stuff up. Looks like I need to update my Azure Functions core tools. I'm going to update it right now. I'm just going to do it. They're already... This really should be a VS Code secrets extension. Yeah, we should make one, Kevin. Wouldn't that be cool? There is a way, for example, if you use REST, there is this thing here. Watch, I'll show you REST. There is a REST, this REST client by Wao Mao that you can do some pretty cool stuff with it. Like this is all I use now for I don't use Postman anymore because you can do all sorts of things like replace things. You can save stuff in a file and do some cool replacements. It's actually really cool. We're doing it live. I wish. Yes, we should do that. I mean, yes, have it like you have like a special file extension so that like instead of like looking like this TS thing, it's like a lock or something. Here, I'll draw the lock. It's like a lock file with a thing that says don't check in. We should do that. Right? Am I right? All right. Sorry, that's from all right, looks like it didn't. Now it's new. Anything else? Is there any updates here? Check for updates. None. We are right as day. By the way, many of you looking at this Visual Studio Code setup are probably thinking, Why does he have it on the right instead of the left? I'm glad you asked. It's because when I move files, right, and I want to get rid of like something, this file doesn't, like, this part doesn't move. So if it was over here and I were to make it smaller, like, everything would move and then my whole world would move. And I don't know if I want to do that. You know what I'm saying? All right. So I think we should start everything up and then see where we're at. So we're in the API. Just to remind ourselves here, what's going on in the API. Oh, by the way, here's all my packages, all my node modules. You got to download the internet for every one of these things, right? Okay. Package.json's npm start. Oh, I think I just... is it npm watch? No, it's npm start. Let's just do an npm start. npm start. Boop. On the API. We'll do another plus here. Boop. We're going to go to the web side of things. Just to remind ourselves, this is a static web app. Static web app. Wait, is it on static web app that we do the horn, or is it on? I don't remember what it was that we do the horn on. Oh, it's on React. That's it. React. So what we'll do is we'll go ahead and start this React app. I'm trying to see. I don't even remember how to start it. Package.json. npm dev or it's yarn dev. There you go. And then what we do is we do this SWA. You know, I wish the SWA command would just do the default. So SWA start. I think I have like a. I'm just gonna have to do SWA start. HTTP localhost, and then this thing is on 3000. 3000. API HTTP localhost 71. Oh, wait a minute. I remember though. We want to debug this. Yes, we want to debug. So I'll F5 instead. F5. Here we go. Okay, there we go. And then this one, once it starts, we can do this other one. Okay. Here we go. I feel like a little kid.
Because y'all can't see this. I'm really sorry about that. I need to go bigger screens here. Sorry.
About that. Okay, so this is going. Now where's my mouse? Where is my mouse? Here it is. Doop. And then I think it's 4248 on the browser here. Doop. Move it from my screens. Did I hit enter on this yet? Or is it just hang? Here we go. I never hit enter. That's embarrassing. 4280. Localhost 4280. Doop. Here we go. Welcome. And you're like, how are you going to make this work if you're already using your camera? Well, I have so many cameras. Like, just to let you know, we are going to be using this one. 046D:082D. If you're wondering. So, boop. It's like two of me now. Two Seths from like different angles. Okay. And then what we wanted to see is, what do we got? It was on the process, we were getting nans. Now I remember. Now I remember. Okay. Let's see if this breakpoint will work. So let's go over here. Let's close Mark Miller down. We don't need these browsers here. Let me close those. Okay. Submit. Oh, yeah, and we squished the picture. Okay, here we go. Okay. So let's take a look at the data. Okay. I remember. I think what happens is that when I send over the data, like, okay. Here we go. Let's look at the data here. Data. What you got? Why isn't it showing it to me? It's still catching up. Data. What do we got here? Let's just F5 this. Oh no. This is what happened last time, right? It like wouldn't let me. Oh, I remember what happened. Everything froze on me. Let's do this. I think we'll wait till this thing catches up. Remember how it just wouldn't do its thing? Let's do this. I think I know what's wrong. I think what's happening is when I send the request over, this frame.data needs to be made into an actual array. Because as I looked at it just briefly, the thing that came out, I can't even see it because this dumb thing right here, you know. Maybe it'll work now. Let's try data. No, it's still not working. Gosh dang it. Now none of these things work. Oh, debugging is awful today for me. It's like, we don't want to tell you what's going on. But what the thing that I'm telling you is what I saw here is I saw a dictionary 0, for example, and then a pixel. 1 and then a pixel. 2 and then a pixel. 3 and then and this dictionary, as it's getting converted, is not working for me. You know? I mean, what do y'all think? All right. I don't see sharp here. We should switch things up. Nice. That was awesome. Yes. Are you a C# dev? I started with C# back in, I'll tell you, I think it was 2003. And I was at I was a senior dev at a VB6 shop. And it was like, I could not get off of that crap soon enough, man. It was awesome. Here's a little convo. Have you looked at sharp things for ML and deep learning? Not yet. There's some cool stuff in deep learning that you can do with deep learning. Like, for example, there's a torch sharp now thing that's actually quite good. Oh, C# dev started recently. Nice. Welcome. You are welcome here. I'm just showing a little bit of AI with TypeScript, which is very similar feeling to C#. Remember that one time where I didn't know anything about TypeScript and someone came to help me? Someone presented. Man, I can't speak today. Someone came to help me. All right, let's see if is this okay. Cool. Okay, so there it is. It took a while, but you can see. Oh, I shouldn't have done that. Dang it! I did it again. What you can see is that the way that this is set up is, I think when this is converting over to an array, it's giving us the Batman problem. You know, I think that's what's happening. So let's just continue this. Let's just F5 it so it can keep going. Go. And what I'm going to do is maybe here in the frame data, we'll convert it to an array. Right? Because this is a, what is this? This is an image data frame. So image data JavaScript. Let's look this up here. Image data JS. Here we go. Here we go. Here we go. Image data with height, color space. Data array is optional, right? One of uint8 clamped array or a float 32 array. Examples. Let new image data. Blah. Data uint clamped array. Canvas. I think it's the uint clamped array that we are working with here when we do this thing. Here we go. What is this? Ugh. I hate that everything stopped. Go. It's like so slow. What's going on? Okay. Uint clamped array. Let's see. Let's see. Here. I think this is what we have. Let's see what this does. Is this like uint clamped array? What does this look like? Set properties from of instance method. What is it? You give me the stuff. Give me the stuff. Array buffer specifications. I wonder if I can convert the uint clamped array, because as I'm passing this thing in here, am I passing it in as an image data? I am. uint8 clamped array. I think the first thing we should do is we should convert this to a regular array. Const pixels equals array dot from data. Will that work? Is there? I think so. Okay. And then what we do, I did that right here. Okay, so let's see what this gives us, because yeah, let's see what this gives us. So I'll let's go back over here to the debug thing. We'll restart it. We'll restart it. So we'll start. Okay, come on. We'll start it again. And this time, let's see what's in here, because maybe this array from is not working for this kind of data, which is a uint8 clamped array. Let's see. Let's see. What we're doing right now is we're trying literally to do prediction. Finally, on the let's do this. All right, here we go. Here we go. There I am. Two of me. Okay, debugger is attached. Let's go to here. Let's take this off, and let's do that. Let's do it. Submit. Remember, we squished myself. Okay. So this T has a bunch of nans in it, which is what we don't want. But we have the data. So data dot data, and then let's try array dot from. Let's see what that does. Nothing. That's what this is our problem. This is our problem. This is what's causing everything to break. I knew it. I knew it. Holy cow, it's already 12:20. My goodness. Where does the time go? All right, so let's go over here. Uint clamped array. So let's take this to float array JavaScript. By the way, if we were doing all of this in Python, how can I convert a uint clamped array to a regular array in which values won't be constrained to 0 to 2? You can't. At least not if you intend to keep the images. Sorry, I was not there. I need to copy into another array, which would be a regular array. Adjusted. Okay. You can convert a typed array to a regular array using array prototype slice. Can you now? Let's see. Thank you, Stack Overflow. Data.data. No, you can't. Is there like a type of data.data? Typo F, weirdo. What are you doing, Seth? Object. Okay. Okay. Maybe it needs to happen at the client side. I need to send the array. Let's try that. Let's see what happens. I mean, what's the worst that can happen? F5. Okay. So the website was rebuilt, and now we're doing the uint clamped array deal from the right spot. So let's do this again. Let's see what happens. All right, let's push it. Let's do it. Submit. Here we go. Let's take a look at the data. Data.data. This still isn't right. What's going on here? No. What's going on? It's right here. Array from. This is what I'm sending over. Maybe. Jeez. What the heck is this doing? Let's see. Let's see what this does here. Here we go. Refresh this. Control Shift I on this. Here we go. We got to figure out what the heck is sending it over. By the way, I'm better at Python when it comes to this stuff. I'm being honest. All right, so let's submit here. What do we got? Submit. Yeah, see? This is an array that we're sending over. But for some reason, when it gets over here, it's this thing. Let's do this. What is this? Height equal rec dot body dot height. And then when we do this, convert to tensor, I'll just do this. Okay, let's make this go away for now. Then we'll go over here, and what I'll do is I'll say data and then height width, and then we'll restart. We'll restart this side. Abort. F5. Cool. So we'll restart this. I think what's happening is when I cast to a uint clamped array, it converts it, I think, like implicitly, which is kind of not cool. Why is it mad at me? Oh, we don't need this. It doesn't exist, so here we go. Debugger attached. Terminal will stop. We'll do it again. Here we go. Attached to node. Here we go. I'm gonna find this email because I want to try to do the other thing too. From remember we had an unsupported offset. Okay, let me ask her. She didn't tell me. Where can I get? Where can I SD? Very good. Okay. Okay. So now it's running again. Now let's see if we can't get it to work. Here we go. Refreshos. I guess I don't need to refresh that part, right? I mean, I guess I don't need to. Let's choose the right camera here. And let's set a breakpoint here. And let's see what we got. Array. Okay, cool. So data. Array. Perfect. 224. 224. What's T look like? Yes! Yes! It should be guessing none. Let's do F10. 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 Whoa. Oh, no, that's right. Right now it's guessing like rock. Why is there... Oh, this dimensions. Dimensions. This is right. It did it. It did its thing. So here's the response. Well, we got to get the response here. Let's get the response then. And let's start putting stuff in. Let's take this out. Doot, doot. I think we're getting somewhere. A response, await fetch. So then... Oh, no, I don't need that. Hold on. What response am I getting out? Not you. We want you. I know what I want. I want response.json. Const data equals await response.json. Okay. And then we want to spit out the data. That's what we want to spit out. Okay. Cool. Let's do it again. Submit. What did it? Why didn't it? We are on this one. We want response.json, right? Which is an any, and then we'll console log it out. Here we go. Nice. Okay. Cool. Okay. So I need to. I don't know why it's 10:49. I don't know why it's 10:49. But basically, it's starting to give us the stuff we want back. So output data. Let's do a little breakpoint here to do this one more time, and I'll hit submit. And then output data. Oh, wait a minute. Remember this model dot output names. So we want 0. Cool. So just like there was an output name, just like there's an input name that we want to pass, and we need to get an output name. So const predictions equals output data model dot output names 0. And we want to send these things back. So let's F5 this so that it'll run, and then we'll restart it. We'll restart this bit. Okay, I think we're getting close. I think we're getting stuff out now. This is cool. By the way, for those that are watching, and you're like, well, what the heck? I thought this was the AI show. Well, I thought we were going to do some AI. Yeah, this is part of AI, like writing the code to get stuff out of the model, right? To bring actual value to what's going on. So I've never done it with Node, to be quite honest, and the Onyx runtime. So I thought it'd be cool to do it. We're at 12:30. So the next thing we have to do, if possible, is when we do this convert to tensor, we have to convert to the right size of image, and that's going to be tough. I don't know how to do. I don't know how to do anything. So let's go back over here, refresh, Control-Shift-I. Control-Shift-I. Oops, did it again. Too many times. Oh, jeez. I keep clicking on the wrong thing, like right when I'm almost done. Please. That was a little dramatic. Oh, that was so dramatic. I feel like I need to... We just want to know what I'm doing. Is it rock? Is it paper? Is it scissors? All right. What do we got here? Preds. That's what we want. Okay. So data dimension. So we'll say cool. So we're going to make a special object, const response equals. And what we'll do is I'm trying to remember the order of the things. Like I don't remember what the order was. So let's go to our let's go to our model here, and in the meta.json, these are the classes. So okay, cool. So I'll take these, and I will have a const classes equal boop, model classes. Okay. And then what we want to do is preds.data. We want to get the max index. So, max index. So const prediction equals preds.data.max. How do you get the max index? The array here. Max index JavaScript. Cool. Why doesn't it like this? I sneezed. No, I've done this before. There's got to be a better way. Let's see. GitHub.com. What was it? Onyx. What was it? Oh, shoot. What was that project called? Vision. Let's go to the client. Components, capture. How did I get the max index? Let's see. Yeah. Oh, I did do it that way. Oh, here. I'm going to just use this. Just to give me the float 32 array. Maybe I need to do the const. Oh gosh, const preds equal float 32 array of preds.data. What the freak? Oh, this. I guess I only need the data. So let me do this. Because I don't need the dimension or the type, right? I don't care. I don't care. So what does this type give me? Okay. It's going to be this. Press. Okay. And we'll just do IDX here. And then we'll do probabilities. Const probs equals preds.map DI Return label. Okay, I know what this is. Model classes I, comma, probability, and then it's going to be it's exactly the same thing. Cool. Okay, so basically what's going on is what happens is the what is this? Why is this mad at me? I'll just stop it. Why isn't this happy? Argument type of number is not a sign of a never. Oh. What are we doing here? What's the hang up? So anyways, let me tell you what's going on. So basically, once you here, I'll just show you the actual model. So let's go to, well, let me show you the one that's getting used here. So it's right here. So we're revealing, this is the actual AI model. The model, like the thing that we built that does the machine, that does the AI. I have to put the picture pixels into it, and out at the end of this thing, here, I'll show you. It's a weird one because we decided to do ShuffleNet because it was tiny. So in comes this picture thing. I think is this as zoomy as I get? So in comes the picture, one picture, three channels, red, green, blue, height, width. Out at the bottom comes out this thing, which is of size 4. So you can see, let me zoom it here a little bit better. So basically at the end, there's like 1,000 things that come out, and then at the end it comes out to 4. And inside of this 4 thing, there's like an array that corresponds to each class. So none, rock, paper, scissors. And the one that has that, let's just see these are like little buckets, right? And the one that has the highest number is the one that we guess. So in this case, since this is supposed to be a line and a bucket full of water, and the value ranges from 0 to 1, because we did a softmax over it, which forces it all to sum to 1. So basically, since this one is like closest to 1, we guess paper, none. This is rock. And so out of the whole thing, like you stick a picture in this, the pixels of the picture, and out of this whole thing comes out 4 numbers. And those 4 numbers tell you which thing you're guessing. And so what I'm doing right now is I'm trying to send back as much information as possible. So for example, the prediction is going to be the model classes, and then the IDX, right? Because that's the max index. And then the probabilities are going to be the probs. Except I don't know why this is having a hard time. Preds.map, arrow function. We're mapping number to number. And we're returning label model classes I. Probability of the number times 100. So this gets us the max index. So model class and index. And this is supposed to do a map over every single item in the predictions. So for each number and the index, we're going to give it a label of the model class as I and the probability E. But I don't know why it's... I don't know why this is having a problem. Argument of type E, number I, blah, blah, is not assignable to parameter of type value. Oh. Array.from. Oh, you heard it. Someone's talking to me on Learn TV. What do we got? What do we got here? Let's refresh here. Somebody said Power BI. Awesome. I don't know how that helps us. All right, what's the problem here? What is the problem here? Maybe I need to force it here, right here. Just do this. Be like, hey, just FYI, this is a this type. Don't need this. All right, here we go. Preds. So float array, which is good. We're going to do a map. The value, the index. Oh, I'm forgetting something. Something's wrong. Let's go back to this thing. I think I'm forgetting something. Sorry, this is super tiny. Control plus here. This is when I did it before. Super tiny. Let's make it bigger. So model labels, right? We got that. Index, blah, blah, blah. And then label this, that model label, blah, 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 blah. Huh? Why isn't this letting me do it? It's not assignable to type number, value, number, index array, float array, number. I'm just going to do it the dumb way. Const probs equals. Oh man, I got 15 minutes. It says props. And then what I'm gonna do is I'm gonna say for I equals 0, I less than preds dot length I plus plus props dot append add. How do you add push? What kind of type is this? The freak, what's going on? I can't do it. I'm so close. JavaScript map array. Here we go. Here we go. Here we go. No, not W3 schools. I don't like W3 schools. Here. This Mozilla, I like their... What? Maybe I'll just use a map. That looks better. Okay. New map. Line 39. Let's see. Spelled probs. Oh, yeah. Let's try this. Let's take this out. Let's take this out. And then what we're going to do is we're going to say probs. There's got to be a smarter way to do this. I'm not being clever. Model classes. I gets a value of probs I. And then we'll just send this back. Okay, let's refresh this, and let's see if we're getting the right thing back. 35 probs, yeah. Thank you. Oh shoot, this is wrong. It needs to be preds. That's the right thing. So let's run this again. And this should return the right thing. Okay. Okally dokally. Here we go. Okay. What you got? No. What are we doing here? Oh, here we go. Okay. Here we go. Oh, it's not running yet. Let's see. Gotta wait. Gots to wait. There we go. Durf! By the way, I predicted the right thing. So that's good. Look at... This is me, like, thinking...
Please work. Please.
Alright. This map thing is dumb. How do I... Dang it. I wish... Freak. I don't even know what this is. What does this say? Pause. Okay. Let's just stop it. Oh, we got 10 minutes here. 10 minutes. 10-minute alert. 10-minute alert. We don't want this. I want to do preds.map callback function value number float array. Predictions dot. It's supposed to return not a join, not a keys. It's the map I want, but float 32 array map is different than a regular array. Reduce. Here we go. Oops. Reduce, right? No, I don't think reduce is the right thing. I thought it was map. Reverse slice set sum Sort subarray to values. No. Yeah, I'm pretty sure it's map. I mean, come on. Callback function. A function that accepts up to 3 arguments. The map method calls the callback function one time for each element in the array, calls a defined callback function on each element array, and returns an array that contains the results. Exactly, which is what I want. So the callback function says I get the value, which is v. I get the index, which is I. And then I guess this is the array. So const R equals boom. Is this the array that I'm adding to? I mean, I don't know. What the heck? Oh no, we gotta do this the right way. Is there like a list? No. Come on, I'm so close. So so everyone's asking, what am I doing? So basically, what I want to do is I want to return something that's like none, colon, and then like 20%. You know, rock, colon, 10%. Paper, colon, 5%. You know what I'm saying? And I'm trying to shape it so that when it returns the probabilities, like this is the prediction, this is the probabilities, right? The problem I have is for some reason I can't go, and it must be like a brain spasm. Because like, look, here, look. Watch. I can do this. No. It's like a dictionary. Is there like a dictionary in here? No. Const. Const probs equals, we'll just put an empty object there. And then what I'll do is I'm just going to do this for let I equals 0, I less than preds dot length I plus plus. I'm going to say probs bracket model classes I equals preds I times 100. And then this goes away. All of this goes away. And that's it. That was dumb. If that was it, then I was just trying way too friggin' hard. You know what I'm saying? Okay. Ah, shoot. It's time to put my walk-off music here. Okay. I think we might have done it. This might be it. I think we did it. Did we do it? I think we did it. Here we go. Refresh. We'll figure out the size thing later. I'm not even setting breakpoints. Get out of here. Oh my goodness. Oh. Ooh. Oh! Full stack AI developer. They're totally wrong. I mean, we can fix that later. By the way, exciting news for you all. Coming up next time, the wonderful Aishigul Yone and B. Stolnitz will be on the show. They are taking over next week. She's back from a bit of a hiatus. She's awesome. You're gonna look. They're just awesome people. So make sure you tune in for that faux show. It's been a privilege being with you. We've got a couple of minutes. Let's see what's coming. Yes, we did it. Nice is right. Next time, we're going to try to unsquish me. And I think we almost got it. So I'm pretty excited about that. Let me make sure here. I have the exact time going on here. This has been super fun. I think overall it's just a little... Like, this stuff is kind of like the sucky part of all it. But you know what? I'm going to figure this out so I can stop debugging that. It's been awesome being with you all this time. Thank you so much for being with us. And as always, if you have any questions, feel free to reach out to me. You can go to SethWires.com. I have a little helpful Ask Me Anything question box for y'all. It's been a privilege being with you. Again, if there's any questions, send me a question in the question box. Next week, we're going to have Aishigul and B. The shows will be great. And then I will be back the week after that with some top secret stuff that hasn't even come out yet. Pretty excited about. Thank you so much for watching. And hopefully, my friends, we will see you on the flippity flip. Take care, my friends.